Bismillahirrahmanirrahim. I am here Muhammad Tayyib from Army Public School and College Khanewal. Your class is 9th and your subject is physics. Week is 6 online sport program. Topic is 4 and your subject teacher is Mr. Muhammad Tayyib. Today our topic is major sources of energy from biomass and mass energy equations. And our objective is at the end of the lesson, students will be able to understand energy from biomass and mass energy equations. And day is 4. First of all, we will discuss our previous topic, geothermal energy. In some part of the world, the earth provides us hot water from geysers and hot springs. There is hot molten part deep in the earth called magma. Water reaching close to the magma changed to steam due to the high temperature of magma. This energy is called geothermal energy. Geothermal well can be built by drilling deep near hot rocks and places where magma is not very deep. Water is then pushed on into the well. The rocks quickly heat the water and change it into steam. It expands and moves up to the surface. The steam can be piped directly into the houses and offices for heating purpose, or it can be used to generate electricity. Now we will come back to our today topics, energy from biomass. Biomass is a plant or animal waste that can be burned or as fuel. Other form of biomass are garbage, farms wastes, and other plants. These wastes are used to run power plants. Many industries that use forest products get half of their electricity by burning bark and other wood wastes. Biomass can serve as another energy source, but problems are there in its use. When animal dung beads plants and dead animals decomposed, they give off a mixture of methane and carbon dioxide. Electricity can be generated by burning methanes. Now I will share you the animation about the energy from biomass that is more helpful to you for learning.
And horse trainer John Kimberlin was buried in a mountain of manure and bedding. The cost for some buildings that needed heat. Kimberlin knew that animal waste is a fuel for heat for thousands of years. Today's technologies to extract the energy found within biowaste. Working with other engineers and professors from Iowa State University and Texas A&M over a period of 12 years, Kimberlin's idea gradually developed into a clean and efficient machine that could deliver more power than he had ever imagined. Kimberlin called his new invention the Nature's Furnace Biomass Reactor. Nature's Furnace uses its patented combustion process to ignite the waste from the inside to create a superheated, horizontal tornado of fire within its combustor. Heat exchangers placed in the heart of the fire harness the energy which, along with machines from biopower boiler and bioelectric, can deliver heated air, heated fluids, air conditioning, and electricity for your facility. Nature's Furnace's biomass reactor system will combust any ground or chopped organic fuel, animal waste, wood fuels, agro waste, and fuel crops. The possibilities for fuel are abundant and full of untapped energy. The combustor converts waste into environmentally friendly energy. Nature's Furnace uses a simple design with only 11 moving parts, providing the machine with its efficiency and reliability. In 1 hour, Nature's Furnace converts approximately 400 pounds of bio-waste into 500,000 BTUs and 100 kilowatts of electricity while using less than 5 kilowatts to operate. At larger operations, additional units can be installed in series to consume more waste. The system eliminates bacteria, parasites, and weed seeds, providing a cleaner, healthier environment for your family, employees, and animals. The only byproducts of the extremely high temperature combustion are sterile pot ash and a nearly smokeless burn, 99% of which is steam. Nature's Furnace has EPA exemption for applications combusting 100% pure biomass. The Attaching an optional catalytic converter makes it compliant to tougher European clean air laws and stricter municipal limits. Nature's furnace was designed with ease of operation in mind. It doesn't require a rocket scientist or an engineer to operate. It's as simple as keeping the hopper loaded with fuel, pressing the control panel start button, and periodically emptying the ash receptacle. Nature's furnace does the rest of the work using 5 augers and 4 vibrators to automatically move the biofuel through the reactor. The state-of-the-art control panel automatically loads the furnace.
Next is your mass energy equations. E is equal to mc square. Einstein predicted that the interconversion of matter and energy. Einstein says that matter convert into energy and energy convert into matter. According to him, a loss in the mass of the body provides a lot of energy. This happens in nuclear reactions. The relation between mass m and energy E is given by the Einstein mass energy equations. E is equal to mc square, where E is the energy, m is the mass, and c is the speed of light, and the value is 3 × 10⁸ meter per second. The above equation shows that tremendous amount of energy can be obtained from small quantity of matter. It appears that matter is highly concentrated from the energy. The process of getting energy from our nuclear power plants is based on the above equation. The process is taking place on the sun and the star for the last millions of years. Only a very small fraction of the sun energy reaches the earth. This is very small fraction of the sun energy is responsible for life on the earth. Now I will show you the video about the mass energy equation that is more helpful to you for learning.
Hi, it's Mr. Anderson, and this is AP Physics Essentials video 66. It's on mass and energy and their equivalents. Remember, Einstein's famous equation showed that energy can be converted into mass, and mass can be converted into energy. In other words, they're equivalent. They're the same thing. And since c is the speed of light, we can get a huge amount of energy from a small amount of mass. So in this first atomic explosion ever, about 1 gram of matter was lost, and that became the energy that you can see. Now that might seem odd, but it's even odder when you look in the other direction. Energy will be converted back into matter. And so in Grand Coulee Dam, it's been calculated that every 4 hours, about a gram of matter is created. And so what is that gram of matter? Well, it's actually heat and light in the towns that that dam serves. And so how could light and heat be matter? Well, they are. If I were to take a slinky, for example, and stretch out the slinky, by adding energy to it, I've actually added mass to the slinky. And if that blows your mind, welcome to the world of special relativity. And so mass and energy can be converted from one form to another. And thankfully, even though that concept is confusing, the equation is very simple. E equals mc squared. E is energy, m is mass, and c is going to be the speed of light. So we can convert one into another. But if we're going from the mass to the energy side, like we would in almost any of these nuclear processes, we're going to get a huge amount of energy from a very small amount of mass. And so how do we measure energy? It's going to be measured in joules. And what is a joule? It's simply a Newton meter. And so if you were to take an apple, which is about a Newton, and you were to raise it, 3 feet or around a meter, that's going to be 1 Newton meter. So it doesn't seem like a lot of energy in 1 joule. If you're to do that in a second, that would be 1 watt of power that you would have. And most light bulbs, to give you an idea, around 60-watt light bulbs, that means that they have enough energy, electrical energy, to lift 60 apples a meter every second. So there's a huge amount of energy found in electricity. But how much energy is locked in the apple itself? In other words, if we were to use Einstein's equation, how much energy could we get out of the mass inside the apple? We know it's going to be a huge amount of energy, but the calculations are really, really simple. E equals mc squared. Remember, we've got energy, mass, and speed of light. So all you do is figure out the mass of an apple. It's going to be around 150 grams or 0.15 kilograms. And then you simply plug it into the equation. So energy is equal to mass, 0.15 kilograms, times the speed of light, squared. So we have to square this value right here. And so if I calculate that, I get around 14 quadrillion joules of energy just found in the matter of the apple itself. And again, In the future, maybe we'll have fusion reactors. We can.
Next is your assignment, learn and write energy from biomass and mass energy equations. Thank you.